All right, and one more example of these. So here's number 24. Find the tangent normal of x sine of 2y and y equals y cosine 2x. And in the book, they didn't put these parentheses here. That's like really egregious faulting of parenthesis use, in my opinion. All right, so we're going to start with by taking d dx on both sides. That's our step one. All right, so we have to watch that it's a product rule, f times g. Oh, they're both product rules, f times g. So on this side, I'm going to have f prime g plus f g prime. Let's see how that falls out. So my f prime is going to be 1. My g is going to be sine of 2y. My f is going to be x. My g prime, I have to watch because it's a chain rule for g prime. So I have derivative of the outside is cosine, keep the inside the same, times the derivative of the inside function, and then a dy dx because it's a derivative of a function in y with respect to x, right? Derivative of the outside, inside the same, g prime, dy dx for the y. All right, equals. Now I have another product rule. So this is going to be f prime g plus f g prime again. All right, so I'm going to have, now f prime this time is 1, but since this is a function in y, it's going to be dy dx because this is a function in y and I did f prime. When I do g, I'm not doing a derivative, g, so I'm not doing a derivative, so it says cosine of 2x. Plus, when I put my f, okay, I'm not doing a derivative, f, we're not doing a derivative, it's not f prime, so I'm just going to put y, I'm not going to put a dy dx. And then for my g prime, I have to do chain rule for g prime, so it's going to be derivative of cosine is negative sine. I'm going to put parentheses here so it doesn't look like I'm subtracting the sign. I'm going to keep the inside function the same, 2x. And then I have to multiply times the derivative of the inside function. That's a g prime, right? This is our chain rules are right here. Let's call that h prime since we've got f's and g's floating around. H prime, that's for my chain rule. But I'm not going to put a dy dx on this one because this was a function in x, so it doesn't need a dy dx. Only functions in y get dy dx's. All right, so there's that. Let's see if we can clean this up a little bit. So I have sine of 2y plus 2x cosine of 2y dy dx equals cosine of 2x dy dx minus 2y sine of 2x. All right, hopefully I didn't miss anything there. If I did, I guess that's just life and I'll get it wrong. Okay, so now dy dx is to the left, everything else to the right. So the sine 2y is going to go over here. So let's bring the cosine 2x over here. So negative cosine of 2x dy dx plus 2x cosine 2y dy dx equals the sine of 2y, we're going to bring it over, negative sine of 2y minus 2y sine of 2x. Yeah, it's a little tedious, but I guess that's life. All right, but here's what we've done. We've brought the dy dx over here, and we've brought the sine of 2y over there. All right, now, next up is we're factoring out the dy dx. So dy dx times negative cosine of 2x plus 2x cosine of 2y equals negative sine of 2y minus 2y sine of 2x. All right, now I'm going to divide both sides by whatever's in front of the dy dx. dy dx equals, this is going to go in the numerator, negative sine of 2y minus 2y sine of 2x over negative cosine of 2x plus 2x cosine of 2y. No way to simplify any of that, so that is our derivative. All right, now we're supposed to find the tangent and normal at pi over 4, pi over 2. So that means we need dy dx evaluated at the point pi over 4, comma, pi over 2. And it really does help me to write under here x and y because I tend to get pretty confused because they're not in the same order over here. Okay, so I got to go negative sine of 2 times pi over 2. So that's going to be negative sine of pi. See, when it's just one thing, then I can leave the parentheses off. Minus 2 y is pi over 2. So 2 times pi over 2, I could just put minus pi here, but I don't want to make it too messy, so I'll put that. And then it's going to be sine of 2 pi, sine of 2x, that's going to be sine of pi over 2, which is 1. So maybe I should just write that right away. I could have done that here. We know sine of pi is 0, right? So we could simplify this a little bit as we go. All right, negative cosine of 2x. Okay, so 2x is going to be 2 pi. Sorry, pi over 4. 2 times pi over 4 is going to be pi over 2. Cosine of pi over 2 is 0, so that term is 0. And then plus 2x, x is pi over 4. So 2x is going to be pi over 2. All right, and then cosine of 2y. So cosine of 2y is going to be cosine of pi, which is negative 1. Okay, I can't vouch for any of this. I'm doing it all in my head. All right, so now this is 0, and this is minus, let's see, the 2's cancel, so I think I just have negative pi in the top. And then in the bottom, it looks like I have negative pi over 2. Okay, and then the pi's cancel out, and I just have 2. Nice. Okay, now that's just the slope of the tangent. So now I have to write, I have no idea if that's right. If I made some little mistake in there, I'm sorry. Now I'm going to go write the equation of the tangent. Y minus pi over 2 equals 2 times x minus pi over 4. Now, when you're writing both things, I should write this is the equation of the tangent. So whoever's looking at this knows what they're looking at. And then for the equation of the normal, I'm going to have y minus pi over 2 equals negative 1/2 times x minus pi over 4. And that's going to be the equation of the normal. All right, there you go. And so you could, if you want, like graph this thing, but I guess there's no way for us to really graph that. I think Desmos does a pretty good job graphing implicit equations like that. I have no idea if we'll actually be able to do that or not. I'm not going to take the time to find out because it's like 6 o'clock right now. All right, so that is it. And then your homework on this, yes, your homework assignment. So your homework on this section is page 162 in your book, number 1 through 11 odd, and number 17 through 23 odd, and number 45. And that's all already posted on the course website if you want to look there, and all the due dates are there too. I won't bother to try and state that now. All right, that's it. Have a good weekend.